Prospect theory. Prospect theory is the earliest theory of behavioral economics and behavioral finance. Developed by Daniel Kahneman and Amos Tversky in 1979, it arguably earned Kahneman the 2002 Nobel Memorial Prize in Economics. It constitutes one of the first economic theories built using experimental methods. Based on results from controlled studies, it describes how individuals assess their loss and gain perspectives in an asymmetric manner, see loss aversion. For example, for some individuals, the pain from losing $1,000 could only be compensated by the pleasure of earning $2,000. Thus, contrary to the expected utility theory, which models the decision that perfectly rational agents would make, prospect theory aims to describe the actual behavior of people. In the original formulation of the theory, the term prospect referred to the predictable results of a lottery. However, prospect theory can also be applied to the prediction of other forms of behaviors and decisions. Overview. The prospect theory starts with the concept of loss aversion, an asymmetric form of risk aversion, from the observation that people react differently between potential losses and potential gains. Thus, people make decisions based on the potential gain or losses relative to their specific situation, the reference point, rather than in absolute terms. This is referred to as reference dependence. These two examples are thus in contradiction with the expected utility theory, which only considers choices with the maximum utility. The theory continues with a second concept, based on the observation that people attribute excessive weight to events with low probabilities and insufficient weight to events with high probability. For example, individuals may unconsciously treat an outcome with a probability of 99% as if its probability was 95%, and an outcome with probability of 1% as if it had a probability of 5%. Under- and overweighting of probabilities is importantly distinct from under- and overestimating probabilities, a different type of cognitive bias observed for example in the overconfidence effect. Model. The theory describes the decision processes in two stages. The formula that Kahneman and Tversky assume for the evaluation phase is, in its simplest form, given by where V, \V, is the overall or expected utility of the outcomes to the individual making the decision, x1, x2, xn, x sub 1, x sub 2, \L. X sub n, other potential outcomes and p1, p2, pn, \P1, p2, P sub n, their respective probabilities, and V, V, is a function that assigns a value to an outcome. The value function that passes through the reference point is S-shaped and asymmetrical. Losses hurt more than gains feel good, loss aversion. This differs from expected utility theory, in which a rational agent is indifferent to the reference point. In expected utility theory, the individual does not care how the outcome of losses and gains are framed. The function pi, \pi, is a probability weighting function and captures the idea that people tend to overreact to small probability events, but underreact to large probabilities. Let x, p, y, q, x, p, y, q, denote a prospect with outcome x, x, with probability p, p, and outcome y, y, with probability q, q, and nothing with probability 1 minus p minus q, 1 pq. If x, p, y, q, x, p, y, q, is a regular prospect, i.e., either p plus q less than 1, p plus q less than 1, or x greater than or equal to 0 greater than or equal to y, x check 0 check y, or x less than or equal to 0 less than or equal to y, x leak 0 leak y, then v, x, p, y, q, equals pi, p, nu, x, plus pi, q, nu, y, vx, p, y, q equals pi, p nu, x plus pi, q nu, y. However, if p plus q equals 1, p plus q equals 1, and either x greater than y greater than 0, x greater than y greater than 0, or x less than y less than 0, backslash display style x less than y less than 0, then
v x p y
q
equals new y
plus pi p backslash display style vx
p y
q equals backslash new y plus backslash pi p backslash left. It can be deduced from the first equation that new
y
plus new minus y new
x
plus new minus x
backslash display style backslash new
y plus backslash new y greater than backslash new x plus backslash new
x
and new minus y plus new minus x
new x
plus new minus x
backslash display style backslash new y plus backslash new
x greater than backslash new x plus backslash new
x.
The value function is thus defined on deviations from the reference point, generally concave for gains and commonly convex for losses and steeper for losses than for gains.
If x
p backslash display style
x
p is equivalent to
y
pq backslash display style
y
pq, then
x
pr
backslash display style x
pr is not preferred to
y
pqr
backslash display style y
pqr, but from the first equation it follows that by
p
new
x
plus by pq new
y
equals by pq
new y
backslash display style backslash by p backslash new x plus backslash by pq backslash new y equals backslash by pq backslash new
y,
which leads to pi pr
new x
less than or equal to pi pqr
new y
backslash display style backslash by pr backslash new x backslash leak backslash by pqr backslash new y.
Therefore
Pi
pq pi p
less than or equal to pi pqr pi pr
backslash display style backslash frac
backslash pi backslash left pq backslash right backslash pi backslash left p backslash right backslash leak backslash
frac
backslash pi backslash left pqr backslash right backslash pi backslash left pr backslash right. This means that for a fixed ratio of probabilities the decision weights are closer to unity when probabilities are low than when they are high. In prospect theory, pi backslash display style backslash pi is never linear. In the case that x greater than y greater than 0, backslash display style x greater than y greater than 0, p greater than p, backslash display style p greater than p, and p plus q equals p plus q less than 1, backslash display style p plus q equals p apostrophe plus q less than 1, prospect
x p y q
backslash display style
x p y
q dominates prospect
x p y
q backslash display style
x p y
q, which means that pi
p new x
plus pi q new y pi
p new x
plus pi q
new y
backslash display style backslash pi p backslash new x plus backslash pi q backslash new y greater than backslash pi p backslash new x plus backslash pi q backslash new y. Therefore pi
p
minus pi
p
pi q minus pi q less than or equal to new
y new x
backslash display style backslash frac backslash pi backslash left p backslash right backslash pi p backslash pi backslash left q apostrophe backslash right backslash pi backslash left q backslash right backslash leak backslash frac backslash new backslash left y backslash right backslash new backslash left x backslash right as yx backslash display style y backslash right arrow x pi
p
minus pi
p
pi q minus pi
q
backslash display style backslash pi p backslash right arrow backslash pi q. But since p minus p equals q minus q backslash display style p apostrophe equals q, it would imply that pi backslash display style backslash pi must be linear. However, dominated alternatives are brought to the evaluation phase since they are eliminated in the editing phase. Although direct violations of dominance never happen in prospect theory, It is possible that a prospect A dominates B, B dominates C but C dominates A.
Example.
To see how prospect theory can be applied, consider the decision to buy insurance. Assume the probability of the insured risk is 1%, the potential loss is $1,000 and the premium is $15. If we apply prospect theory, we first need to set a reference point. This could be the current wealth or the worst case, losing $1,000. If we set the frame to the current wealth, the decision would be to either 1. Pay $15 for sure, which yields a prospect utility of V minus 15 \displaystyle V minus 15. Or 2. Enter a lottery with possible outcomes of $0, probability 99%, or minus $1,000, probability 1%, which yields a prospect utility of pi 0.01 times V minus 1000 plus pi 0.99 times V 0 equals pi 0.01 times V minus 1000 \displaystyle \pi 0.01 times V minus 1000 plus \pi 0.99 times V 0 equals \pi 0.01 times V minus 1000. According to prospect theory, the comparison between pi 0.01 \displaystyle pi 0.01 and V minus 15 V minus 1000 \displaystyle V minus 15 /V minus 1000 is not immediately evident. However, for typical value and weighting functions, pi 0.01 greater than V minus 15 V minus 1000 \displaystyle pi 0.01 greater than V minus 15 /V minus 1000, and hence pi 0.01 times V minus 1000 less than V minus 15 \displaystyle pi 0.01 times V minus 1000 V minus 15. That is, a strong overweighting of small probabilities is likely to undo the effect of the convexity of V \displaystyle V in losses, making the insurance attractive. If we set the frame to minus $1,000, we have a choice between V 985 \displaystyle V 985 and pi 0.99 times V 1000 \displaystyle pi 0.99 times V 1000. In this case, the concavity of the value function in gains and the underweighting of high probabilities can also lead to a preference for buying the insurance. The interplay of overweighting of small probabilities and concavity convexity of the value function leads to the so-called fourfold pattern of risk attitudes: risk-averse behavior when gains have moderate probabilities or losses have small probabilities, risk-seeking behavior when losses have moderate probabilities or gains have small probabilities. Below is an example of the fourfold pattern of risk attitudes. The first item in each quadrant shows an example prospect. For example, 95% chance to win $10,000 is high probability and a gain. The second item in the quadrant shows the focal emotion that the prospect is likely to evoke. The third item indicates how most people would behave given each of the prospects, either risk-averse or risk-seeking. The fourth item states expected attitudes of a potential defendant and plaintiff in discussions of settling a civil suit. Probability distortion is that people generally do not look at the value of probability uniformly between 0 and 1. Lower probability is said to be overweighted, that is, a person is over-concerned with the outcome of the probability, while medium to high probability is underweighted, that is, a person is not concerned enough with the outcome of the probability. The exact point in which probability goes from overweighted to underweighted is arbitrary. However, a good point to consider is probability equals 0.33. A person values probability equals 0.01 much more than the value of probability equals 0. Probability equals 0.01 is said to be overweighted. However, a person has about the same value for probability equals 0.4 and probability equals 0.5. Also, the value of probability equals 0.99 is much less than the value of probability equals 1, a sure thing. Probability equals 0.99 is underweighted. A little more in depth when looking at probability distortion is that pi p plus pi
1 minus p, less than 1, whereby p is probability and prospect theory. Applications.
Economics. Some behaviors observed in economics, like the disposition effect or the reversing of risk aversion/risk seeking in case of gains or losses, termed the reflection effect, can also be explained by referring to the prospect theory. An important implication of prospect theory is that the way economic agents subjectively frame an outcome or transaction in their mind affects the utility they expect or receive. Narrow framing is a derivative result which has been documented in experimental settings by Tversky and Kahneman, whereby people evaluate new gambles in isolation, ignoring other relevant risks. This phenomenon can be seen in practice in the reaction of people to stock market fluctuations in comparison with other aspects of their overall wealth. People are more sensitive to spikes in the stock market as opposed to their labor income or the housing market. It has also been shown that narrow framing causes loss aversion among stock market investors. And their work, that of Tversky and Kahneman, is largely responsible for the advent of behavioral economics, and is used extensively in mental accounting. Software. The digital age has brought the implementation of prospect theory in software. Framing and prospect theory has been applied to a diverse range of situations which appear inconsistent with standard economic rationality: the equity premium puzzle, the excess returns puzzle, and long swings/PPP puzzle of exchange rates through the endogenous prospect theory of imperfect knowledge economics, the status quo bias, various gambling and betting puzzles, intertemporal consumption, and the endowment effect. It has also been argued that prospect theory can explain several empirical regularities observed in the context of auctions, such as secret reserve prices, which are difficult to reconcile with standard economic theory.
Politics.
Given the necessary degree of uncertainty for which prospect theory is applied, it should come as no surprise that it and other psychological models are applied extensively in the context of political decision-making. Both rational choice and game theoretical models generate significant predictive power in the analysis of international relations (IR). But prospect theory, unlike the alternative models, 1. is founded on empirical data, 2. allows and accounts for dynamic change, 3. addresses previously ignored modular elements, 4. emphasizes the situation in the decision-making process, 5. provides a micro-foundational basis for the explanation of larger phenomena, and 6. stresses the importance of loss in utility and value calculations.
Moreover, again unlike other models, prospect theory asks different sorts of questions, seeks different evidence, and reaches different conclusions. However, there exist shortcomings inherent in prospect theory's political application, such as the dilemma regarding an actor's perceived position on the gain-loss domain spectrum, and the discordance between ideological and pragmatic, i.e. in the lab versus in the field, assessments of an actor's propensity towards seeking or avoiding risk.
That said, prospect theory is still used and foremost employed by IR theorists today, on predominantly security-related matters. For example, in wartime, policymakers, when in a perceived domain of loss, are more likely to take risks that would otherwise have been avoided, for example gambling on a risky rescue mission, or implementing radical domestic reform to support military efforts. Or, with regards to domestic governance, politicians are more likely to phrase a radical economic policy as one ensuring 90% employment rather than 10% unemployment, because framing it as the former puts the citizenry in a domain of gain, which is thereby conducive to greater populace satisfaction. On a broader scale, consider an administration debating the implementation of a controversial reform, and that such reform yields a small chance for a widespread revolt. Disutility induced by loss aversion, even with minute probabilities of said insurrection, will dissuade the government from moving forward with the reform. Limits and extensions. The original version of prospect theory gave rise to violations of first-order stochastic dominance. That is, prospect A might be preferred to prospect B even if the probability of receiving a value X or greater is at least as high under prospect B as it is under prospect A for all values of X, and is greater for some value of X. Later theoretical improvements overcame this problem, but at the cost of introducing intransitivity in preferences. A revised version, called cumulative prospect theory, overcame this problem by using a probability weighting function derived from rank-dependent expected utility theory. Cumulative prospect theory can also be used for infinitely many or even continuous outcomes. For example, if the outcome can be any real number. An alternative solution to overcome these problems within the framework of classical prospect theory has been suggested as well. Critics from the field of psychology argued that even if prospect theory arose as a descriptive model, it offers no psychological explanations for the processes stated in it. Furthermore, factors that are equally important to decision-making processes have not been included in the model, such as emotion. A relatively simple ad hoc decision strategy, the priority heuristic, has been suggested as an alternative model. While it can predict the majority choice in all one-stage gambles in Kahneman and Tversky, 1979, and predicts the majority choice better than cumulative prospect theory across 4 different datasets with a total of 260 problems, this heuristic, however, fails to predict many simple decision situations that are typically not tested in experiments, and it also does not explain heterogeneity between subjects. An international survey in 53 countries, published in Theory and Decision in 2017, confirmed that prospect theory describes decisions on lotteries well, not only in Western countries, but across many different cultures. The study also found cultural and economic factors influencing systematically average prospect theory parameters. A study published in Nature Human Behaviour in 2020 replicated research on prospect theory and concluded that it successfully replicated. We conclude that the empirical foundations for prospect theory replicate beyond any reasonable thresholds.